I'm going to look at that drop first. The time it takes that drop to fall is I'm going to use capital T's for these periods so that I don't get them confused. These are all capital T's. And that's when it starts from an initial velocity of 0 and falls a displacement that is unknown. Let's label it. I'm going to label this x. And we don't know the final velocity. From the top of the window to the bottom of the window, the time it takes is 1 period. It falls with an initial velocity that is unknown. We'll have a final velocity that is unknown, but falls a delta x of 1.2 meters. And now from the top of the building to the ground, I don't know, we can go top to the ground. We know that the time it takes is 4t. The initial velocity was 0. Final velocity is unknown. And delta x is unknown. And last, certainly not least, but we have some more information. I'm going to bring these together. We have one more we can talk about from the bottom of the window to the ground. The time is 1 period, t. The initial velocity is unknown. The final velocity is unknown. And delta x is unknown. Now, I'm just going to go out on a limb here and make this y. So I have another variable. Because I know this one would be y. This one would be x plus 1.2 plus y. Now, just for fun, this final velocity is this initial velocity, right? This final velocity is this initial velocity. And these two are the same. Now, all of these share the same acceleration, 10 meters per second squared. The question comes down at this point, is there any way we can assemble two equations with two unknowns using the information that's presented here? I've tried to present every possible scenario we have. So let's see if we can find any way to get an equation with two unknowns. I don't know that I see one yet. Maybe we have to go 3 equations and 3 unknowns. That seems mean.
Mr. Sheldon?
Yes.
It says the second and third drops are the ones that are at the top and bottom of the window.
Uh-huh. Didn't I do that?
That's the third and the fourth.
Are you sure? Isn't this drop number 1, this drop number 2, this drop number 3, this drop number 4, and this drop number 5?
Oh.
I mean, I don't have a picture in front of me. I thought the first drop would be the first one to hit the ground.
Yes. No, that was my B.
Yes, no?
Yes.
Okay.
You were correct.
Well, I'm not trying to be correct. So I think I made a mistake, though. I never talk about going from the top of the building to the bottom of the window. I'm saying that because I think that could be the way to solve the problem. Let me show you. I think I have a lot of stuff here I don't need. So I'm going to just gut it. You all wrote it down already, but I'm out of space on my little platform here. So I'm going to gut all of this because I think there's a way to get to the answer. In my head, I'm thinking right now, if I do top of the building to the top of the window or top of the building to the bottom of the window, from the top of the building to the bottom of the window, the time period is 3t. The initial velocity is 0. Delta x is x plus 1.2. And a is 10 meters per second squared. I can construct a motion equation with these 4 things. It would have 2 unknowns. And I can construct a motion equation with these 4 things. It would have 2 unknowns. I think that's how we could solve the problem. It would create 2 equations and 2 unknowns. Now I get that this one's hard, and laying all this data out is exactly what I would expect you guys to do. Lay out everything you can, every combination, and see if you can find one that kind of fits together. This one appears to fit together, meaning I'm going to use 1/2 a t squared plus v naught times t equals delta x. That's from the top of the building to the top of the window. Or 1/2 a t squared plus v naught times t equals delta x. Can you guys see that all right? Or is it just too bright? I could just turn my head off. That doesn't sound as cool as it is, but I could just do it. By head. Now, won't this get us the answer? Doesn't this create 2 equations with 2 unknowns? So the 5 drops was a distraction. Didn't actually need to know there was 5 drops. And the fact that 5 drops perfectly fit was just to help us count off drops on the building. But I think this will do it. Now, I don't want to finish the problem because I think you guys can finish the problem, right? I hate it when I say that and it gets quiet. That makes me sad. Let me stop before I go any further because 4th period, guys, I get very little feedback from this class, and it bugs me because I know so many of you in this class. I'm surprised I'm not getting more feedback. But do you understand what I did to get to this point? If not, we should talk about it more. Okay?
So, for these 2 equations, like, did you take the 1.2 to the other side and then set them equal to each other?
That is a method that will solve this problem. Abigail? I can't hear you. I'm sorry. I don't know what it's on. I thought somebody said 1.2. Is it 2 meters for the distance between the size of the window? Oh, mastering probably wants you to use 9.8. I'm using 10 though. Why? Because I think that's stupid to use 9.8. Well, if we're good, I'm gonna use Skylar's. You're right. Didn't we just do it in 4 minutes?
I was so confused in like 7 minutes.
Okay, so let's before we go any further, there's no magic here. First, I assigned a question. You're right. I've never done this question before. It just sounded a lot like the other question that we did in class. So, what you saw is what I would do to attack this problem. I broke the problem up into parts. And then I started to see if I could find any commonality between the parts. I figured there had to be a reason they were using the 5 drops. And so I drew a picture, gave it some labels, and started looking for common pieces within the problem that I could process together. But at the same time, if you've put in 15 minutes thinking about a question and you have made no progress, it is time to seek help. But if you've put in 2 minutes and made no progress, it is not time to seek help. Understand the difference? I'd even say if you've put in 10 solid minutes, it's time to seek help. I told you I was giving you a scattering of approach. It works. So, darn it, there. So that'd be 1/2 times 5 times 2t squared minus 1.2 equals 1/2, that should be 10, times 10 times 3t squared. Is that what you did, Skylar?
I haven't done anything actually, but that's what I would do.
Well, that's what I'm doing too. Funny. I think that's right. I just moved the 1.2 over.
Isn't the 1.2 on the 3D equation? It should be on the right side of it.
That looked better in my head. I was wondering how could there be less time and I would need to subtract something from it. So there, that looks better. That looks better. Thank you for correcting me. All right, so I just got to do this, right? This is going to be 5 times 4, 20t squared. And that's going to be 5 times 3 squared, 9. 5 times 9, 45. T squared minus 1.2. Did I math correctly? I think I mathed correctly. So 25 t squared equals 1.2. So t is going to equal the root of 1.2 divided by 25. Boom. You've got t. You can figure out the rest of your stuff. I'm all okay with this problem. Yeah, not so bad. Yeah, take that, mastering. You think you own me. Not so much. I could totally rule mastering, although I'll probably have to submit the question like 5 times because I'll probably type it in wrong. I'll probably use too many significant figures. I will use 10 and not 9.8. And I didn't specify up or down, and they might want you to. I don't know what they're asking. I don't even know what the question is. How tall is the building? Well, we know it takes 5 time periods to get to the bottom. And that should help you figure out how tall the building is. You have 1 time period. No, it takes 4. I'm sorry, 4 time periods to get to the bottom. 5 drops, 4 time periods. Whew. Who would assign that to you guys? This guy, right here. That's right. This guy would do it. I would totally do it. I would do it again. I mean, totally do it again. All right, anything else on mastering? I'm sure you're going to say yes, but let's see what you got. This problem for 4 days?